Welcome to Brain Vision.
Our question is: a turbojet aircraft flies with a velocity of 100 km per hour. Velocity is given, that is 1100 km per hour. At an altitude where the air temperature and the pressures are -35 degrees centigrade and temperature is and pressure is 40 kilopascal. Air leaves the diffuser at 50 kilopascal. This is P2 pressure with the velocity V2 of 15 meters per second. And combustion gases enters the turbine at 450 kilopascal. This is pressure P3, that is 450 kilopascal, and temperature T2 is 950 degrees centigrade. The turbine produces 800 kilowatt of power, 800 kilowatt of power, all of which is used to derive the compressor. Assuming an isentropic efficiency of 83%, for the compressor, turbine and nozzle. For the compressor, turbine and nozzle. Using variable specific heats, determine the pressure of combustion gases at the turbine exit. The mass flow, we have to find the pressure, mass flow rate, the velocity of the gases at the nozzle's exit, and the propulsive power, propulsive efficiency for this engine. Propulsive power and propulsive efficiency. Value of gas constant R is given to 0.287 kilojoule per kg dot K. First we will draw the TNS diagram. Four, five, six. It is to be noted that enthalpy is a function of temperature only. Note that enthalpy is a function of temperature only, whereas entropy is function of both only, where entropy is a function of both temperature and pressure. Temperature and pressure. Now first for that we will work for a diffuser. In the process 1 to 2. T1 temperature is minus 35 degrees centigrade, at which H1 is equals to 238.636 kilojoule per kg. H1 is plus V1 square divided by 2 is equals to H2 plus V2 square divided by 2. We will put the values over here. 238.36 plus 1100 divided by 3.6 divided by 2 whole square. This is kilometer per hour, so we are changing into meter per second. So dividing by 3.6 into 1 kilojoule per kg divided by 1000 meter square per second square is equals to H2 plus 15 meters per second square divided by 2 into 1 kilojoule per kg divided by 1000 meter square per second square. So from here value of H2 will be 284.93 kilojoule per kg. For this value of H2, P2 value is 50 kilopascal. For both, entropy value is 5.8513 kilojoule per kg dot K. Now for a compressor, process 2 to 3, pressure P3 is equals to 450 kilopascal and S3 is equals to S2, that is 5.8513 kilojoule per kg dot K. For this pressure and entropy, value of H3S is equals to 534.42 kilojoule per kg. Now the efficiency for a compressor is equals to H3S minus H2 divided by H3 minus H2. Putting the values 0.83 is equals to 534.42 minus 284.93 divided by H3 minus 284.93. So from here we will solve for H3 and H3 values come out to be 585.52 kilojoule per kg. Now for a turbine, that is process 3 to 4. Temperature T4 is given, that is 950 degrees centigrade, at which the value of H4 is equals to 1305.2 kilojoule per kg. At this value, we will calculate the value of H5 from the relation H3 minus H2, H4 minus H5. So from here H5 is equals to 1004.6 kilojoule per kg. By putting the values that are 585.52 minus 284.93 equals 13.05 minus H5 and minus H5, and the value of H5 will come out with this. Where the mass flow rate for a turbine through compressor and turbines through compressor and turbine are assumed to be equal. Efficiency of a turbine is equals to H4 minus H5 divided by H4 minus H5s. Putting the values wherein 5 minus H5s. So from here H5s is equals to 943.04 kilojoule per kg. At temperature T4 and pressure P4, 950 degrees centigrade, and H5s is equals to 962.45 kilojoule per kg, at which value of S5 is equals to S4, that is 6.7725, at which pressure P5 is 136.9 kilopascal. So now the mass flow rate through the compressor is the compressor is m dot is equals to Wc power divided by H3 minus H2, that is 800 kilojoule per second divided by 585.52 minus 284.93, and the answers come out to be 2.661 kilojoule per second. Now working for a nozzle during the process 5 to 6. H5 and P5. Write the values. H5 is equals to 1004.6 kilojoule per kg and P5 is 136.9 kilopascal. S5 is equals to 6.83 A2 kilojoule per kg dot K. Now we will work for a nozzle, and for P6 pressure, S6 value is equals to S5. P6 is 40 kilopascal and this is 6.8382 kilojoule per kg dot K. At both the values, value of H6X is equals to 713.12 kilojoule per kg. So now the efficiency for a nozzle is equals to H5 minus H6 divided by H5 minus H6S is equals to 0.83 equals 1004.6 minus H6 divided by 1004.6 minus 713.12. So value of H6 will be 762.68 kilojoule per kg. Now H5 plus V5 square divided by 2 is equals to H6 plus V6 square divided by 2. Now put the values here to solve for velocity. V6 1004.6 plus 0 equals to 762.68 plus V6 square by 2 into 1 kilojoule per kg divided by 1000 meter square per second square, and the answer comes out to be 695.6 meters per second, where the velocity at the nozzle inlet is assumed to be 0. Where the velocity at the nozzle inlet is assumed 0. So now we will calculate the propulsive power and propulsive efficiency. Propulsive power WP equals to V6 minus V1 into V1, which is equals to 2.661 into 695.6 minus 1100 divided by 3.6 into 1100 divided by 3.6 into 1 kilojoule per kg divided by 1000 meter square second square. Answer would be 317.2 kilowatt. This is the propulsive power. Now heat added is equals to m dot into H4 minus H3 is equals to 2.661 into 1305.2 minus 585.52. The answer would be 1915 kilowatt. So finally the efficiency, propulsive efficiency will be equals to propulsive power divided by heat added. Putting the values, answer would be 0.1656, that is Efficiency is 16.6%. This is our answer. Thank you.